Okay, let's look at the other type, second type of solving first order higher degree differential equations. The first one we looked at was solvable for P. So now let's look at equation solvable for X. So let there be a function of X, Y and P. Let's say it can be solved for X in terms of Y and P. So which means X is equal to f of y comma p. So in which case dx by dy would be phi of y comma p comma dp by dy. Now dx by dy would be 1 by p equal to phi of y comma p comma dp by dy, and this would be a first order differential equation in y and p with a constant c. So let's say this is f of p comma y comma c. Using this we can eliminate p from f of x comma y comma p equal to 0 to get the solution. Okay, let's actually see how this works. Let's say the equation is y minus 2px plus yp square is equal to 0. Yes. Now we have to solve it for x. So minus 2px is equal to minus yp square minus y. So let's multiply the entire thing with minus 1. So 2px is equal to yp square plus y. X is equal to yp square by 2p. Let 2 be here itself, plus y by p. Now let's differentiate with respect to y. Okay, so when we differentiate we get 2 times dx by dy is equal to y as it is dp by dy plus p as it is dy by dy, that is 1, plus now y by p, p as it is and y, then minus y as it is dp by dy by p square. So this would be y dp by dy plus p by p square minus y dp by dy by p square. So one of the p's get cancelled. So 2 by p, we can say dx by dy would be 1 by p. Let's bring this p to this side. So minus p is equal to, and let's bring 1 by p also, this one, minus 1 by p is equal to y minus y by p square dp by dy. Now 2 by p minus 1 by p is 1 by p. So 1 by p minus p is equal to, and here let's take out y common out. So 1 minus 1 by p square dp by dy. Now let's bring both to this side. So 1 by p minus p minus y times 1 minus 1 by p square dp by dy equal to 0. How do we make this is equal to this? Let's take out p out. Let's take out p. So since we have taken out p, this would become p square, 1 by p square minus 1 minus y 1 minus 1 by p square dp by dy equal to 0. But now it is signs are different. So let's take out minus also. So it becomes 1 minus 1 by p square minus y times 1 minus 1 by p square dp by dy. Okay, now what we can do is we can take out minus common, and that minus can go to the other side, or we multiply the entire thing by minus 1. So this becomes plus, this becomes plus, right? So this and this are common. So we can say 1 minus p by 1 by p square times p plus y dy dp by dy equal to 0. Now, since this doesn't have dp by dy, we will ignore that and let's take this. So p plus y dp by dy is equal to 0. Now we have to solve this. This is a first degree, first order. So this we can solve it using separating the variables. So y dp by dy is equal to minus p, y by dy is equal to minus p by dp, and we can bring it to this side itself. So p by dp equal to 0. Let's take the reciprocal of this. Reciprocal. So dy by dy by y plus dp by p is equal to 0. dp by p is equal to 0. We have to integrate. So now this would be log of, or let's write that step by step again, integral of dy by y plus integral of dp by p is equal to, let's hold on for this. Now this would be log of y plus log of p. This we take it constant as log of c. So this would be log of c. Now this can be written as log of py equal to log c. Let's exponentiate both sides. So this and this gets cancelled, and we have py is equal to c, or p is equal to c by y. So we have got p now in terms of c and y. Let's substitute it back. So y minus 2px plus yp square is equal to 0. So y minus 2 times c by y times x plus y times c by y square equal to 0. y minus 2cx by y plus c square y by y square. One of this gets cancelled. y square minus 2cx plus c square is equal to 0. y square minus 2cx plus c square equal to 0. y square minus c is common, so 2x minus c equal to 0, or y square is equal to c times 2x minus c. So you can stop at any point here. Let's do one more. Okay, so p cube minus 4xyp plus 8y square is equal to 0. Now solve for x. So minus 4xyp is equal to minus 8y square minus p cube. Okay, so multiply the entire thing by minus 1, so all become plus. X is equal to 8y square by 4yp plus p cube by 4yp. So y gets cancelled, p gets cancelled, so x is equal to 8y by 4p. So 4 2's, or I could have done this 4 2's here, and here I could have written 2y by p plus p square by 4y. Now let's differentiate with respect to y. Why specifically y? Because then only we will get dy by dx, and we can put that in terms of p. Okay, so dx by dy is equal to, and this would be p times 2 minus 2y dp by dy by p square, plus this would be 2yp, or rather y times 2p dp by dy minus p square by 4y square. See, this 4 will remain as it is. You won't square this because this will go out of the differential and then come back in. So this would not change. Okay, so now this dx by dy can be written as 1 by p, and then let's simplify it. So 2p by p square minus 2y by p square dp by dy plus y by 4y square 2p dp by dy minus p square by 4y square. So here anything will get cancelled. Here p and this will get cancelled. One of the y's will get cancelled. Okay, so 1 by p. Let's bring this to this side, so this becomes minus 2 by p. What else we can bring in? This as well, so minus plus p square by 4y square is equal to this would be minus 2y by p square plus 2p by 2 times 2, so which means I can write it as p by 2y dp by dy common. Okay, now this can be written as p square by 4y square minus 1 by p. Let's bring that to this side, so this can be written as p by 2y minus 2y by p square dp by dy is equal to 0. See, this is the trickiest part, converting this subtraction into multiplication. So now you see, this is p square by 4y square, this is p by 2y, right? So which means here also it should be p by 2y. So let's take out p by 2y and see what happens. So p by 2y. Now this 1 by p multiplied, this multiplied by something should become 1 by p. So which means denominator there has to be a p, but one p is already there, so p square. So when we multiply it, one of the p's will get cancelled. Okay, and here it will be 2y, so that they get cancelled out. Minus 1 times p by 2y minus 2y by p square dp by dy equal to 0. Yes. Now this and this is common, so let's take it out. P by 2y minus 2y by p square times p by 2y minus dp by dy. Now this we can ignore because it doesn't contain dp by dy. So let's continue with this. So p by 2y minus dp by dy is equal to 0. Now we have to integrate this. So let's first separate the variables. This is first order, first degree differential equation. So this will do it like this. 2y dp, no, not 2y, dp by dy. Now let's just move them around so that this becomes p by dp is equal to 2y by dy. And let's take the reciprocal on both sides. So this becomes dp by p is equal to dy by 2y. Let's take this 2 to this side. Now let's integrate. So when you integrate, what do we get? This 2 goes out, so 2 remains as it is. Log of p is equal to log of y plus log of c. This can be written as log p square minus log y is equal to, or what we can do is equal to log yc. And now exponentiate both sides. So this and this gets cancelled. P square is equal to yc. Now let's just see for fun what happens if I bring, so this becomes, bring log y to this side. So it becomes log p square minus log y is equal to log c. What we can do is log rules. So this becomes p square by y is equal to log c. Exponentiate. So this becomes p square by y equal to c, or p square is equal to cy. So as you notice, it's the same. So it doesn't really matter in what order you do it. Okay, so which means now this can be substituted back into our original equation. Okay, let's do that. X is equal to, either we can take up this equation where we solved it for x, or what we can do is we can say p cube minus 4xyp plus 8y square equal to 0. Now let's substitute p square. So this would be what? This is p square times p. P would be equal to square root of yc. So this would be cy square root of cy minus 4xy square root of cy plus 8y square equal to 0. So here p has disappeared now. Now let's see what we can do. Let's take cy common, square root of cy common. So cy minus 4xy is equal to minus 8y square. Now let's square both the sides. Square. So this becomes cy, and this we can square it separately. So this becomes c square y square minus 4 times 2 8 cxy square plus 16x square y square is equal to 64y4. Now remember, this all is pure algebra. So cy, now y square we can take it out. So this becomes y cube, and here we are left with c square minus 8xy square. No, y square we are taking out. So cx plus 16x square is equal to 64y cube. So this y cube, this is 4. So this will get cancelled and we are left with y only. So this, can we factorize this? Can we simplify this? This is c, this is 4x the whole square, and if we multiply square this, we will get 4 to 8cx, correct? Since minus is there here, minus is equal to 64y. Now this can be written like this, or it could also be written as 4x minus c square is equal to 64y. There are various forms in which it can be written. This is the solution. Okay, let's very quickly do one more. Y is equal to p square y plus 2px. Now see, when we are solving these problems, we will just start solving it. But since here we are learning, we just now solved one problem. The first problem was what? First problem was y minus 2px plus yp square is equal to 0. Now tell me, what is the difference between these two? Now if we, if we make it equal to 0, then we will be able to do a proper comparison. So y minus 2px minus yp square equal to 0. So the difference is in this sign. So let's see that difference in sign. How does it differ? Or how does our working out change? And since we already know now, let's do it very quickly. Okay, let's solve it for x. So 2px is equal to y minus p square y. So 2x is equal to y is common. So 1 minus p square by p. Now this can be written as y by p minus yp. Now let's differentiate with respect to y. We get 2 dx by dy is equal to p minus y dp by dy by p square minus p plus y dp by dy. Now if we take the LCM on this side, what happens? We can, after doing that, we can take this to this side. So this will become 2p square dx by dy, and here it would become p minus y dp by dy minus, and we would have multiplied this. So p square p plus y dp by dy, right? Just think about it a little. Take the LCM, add them, and then p square goes to the other side. Okay, now let's see. 2p square by p, because dx by dy is 1 by p, is equal to p minus y dp by dy minus p cube minus p square y dp by dy. One of the p's get cancelled. 2p minus p plus p cube is equal to, minus is common, y is also common, so dp by dy plus p square dp by dy. Now 2p minus p is p plus p cube plus y times, now the dp by dy we can take it out common, so 1 plus p square dp by dy is equal to 0. Now here p we can take it out, so p plus, now 1 plus p square plus y times 1 plus p square, okay, dp by dy. Now let's take out, this is common, this is common, so we can do this p plus y dp by dy times p 1 plus p square. Okay, we can ignore this because it doesn't have dp by dy. So let's take p plus y dp by dy equal to 0. Now separating the variables to integrate this, so this becomes y by dy is equal to minus p by dp, or reciprocal if we take dy by y is equal to, or we can bring it to this side itself, plus dp by p equal to 0. Now we integrate, so this becomes log of y plus log of p is equal to log of c. This becomes log of yp is equal to log of c. So exponentiate both sides, so they get cancelled out. Yp equal to c, or p is equal to c by y. Now let's substitute it back into our original problem equation. So y is equal to p square y plus 2px. Let's substitute p, so y is equal to c square by y square y plus 2cx by y. One of the y's get cancelled, y is equal to c is common, c by y is common, so we are left with c plus 2x. Y square is equal to c times c plus 2x. The difference is, in the first problem the solution was y square is equal to c times 2x minus c, right? So this is for the first problem and this is the solution for this problem. So be careful, and especially signs, when you are moving the terms around, you need to be very careful. Okay, I think that's enough for today. Bye for now.